Okay, so today we learned about solving separable differential equation. So we want to apply a general method for solving separable differential equation. So I will introduce what is the separable differential equation. Then I show you how to solve separable differential equation step by step. So it's just follow step by step. You can do it. Yeah. The important thing is you need to know some algebra skill more than like it's kind of harder than like how to solve the separable differential equation. To solve separable differential equation, you just try to separate the variables. Then you integrate both sides. Then you try to solve for the function you want to find. Okay, so let me write out. We want to apply like a general method to solve the SDE, separable differential equation. The separable differential equation have a form like dy over dt, and the right hand side of the equation is f of t times v of y. So when you look at the equation right here, whenever you see like dy over dt, the dy over dt right here, it means like y is a function of t. Y is a function of t, and we want to find y of t. Y is a function of t. So it means t is independent variable, and y is a function of t. Whenever you see like dy over dt, okay, and f of t, g of y right here. F of t is a function only of t. And g of y is a function of y only. Yeah. It means like you see like right here, right? F, T, G, Y, they separate. They know like in the function of F, no Y. In the function of G, no T. So you can like separate easily to T to one side and Y to the one side. And let me just introduce you like the definition. So if f of t equal 1, then the equation have a name. It's autonomous. Yeah, just introduce. Yeah, you don't need to know that, but like I just make sure I just introduce the definition of autonomous differential equation. Maybe like some of you will take like math 46 in future. Yeah. Okay, so how we can solve this equation? Like this equation, you have the name is separable differential equation, right? How you can solve that? Just follow step by step. Step one. Okay. Step one is you try to separate y and t. Like one side only has y, and one side only has t. Usually, like the side has y is the right hand side, and the side only has c is the left hand side because it's easier. Remember, like we want to find y of t. We want to find y of t. So you put y in the left hand in the the left hand side. The you put the y in the left hand side is much easier. It, you skip like you save some step to solve for y. Yeah, just normally like when you solve the linear equation or the quadratic equation, right? You have like the thing you want to solve, you put in the left hand side. The other thing you put in the right hand side. When you solve for linear or the quadratic. Okay, how you can separate y and t in one side from this equation? So the thing is, you can, let me write down again. Now, from here, you can just divide both sides by z of y. I divide both sides by z of y. And also, I times both sides by dt. Okay, so you can see that from this equation right here, I divide both sides by z of y. And I times both sides by dt. When I do that, I can cancel out dt here. And also I can cancel out g of y here. So now I only have dy over g of y and f of t dt. Yeah. So you can see that the left hand side is only y and the right hand side is only t. The first step is the most important step, right? Because like if you mess up the first step, the whole problem will mess up. Maybe like you, if you mess up the first step and you make the problem harder, it's more complicated. Even you cannot how to solve. You even like it's hard to solve, and sometimes you make problem easier to solve. So the first step, you make sure you separate. It's not easy, but make sure like you do the first step is correctly. Yeah. Okay, so move to the step 2. After you separate one side with only y and one side with t, you can integrate both sides. Integrate both sides. So the left hand side is only y. So the left hand side is integrate respect to y, and the right hand side is respect to t. Okay, so it means you put in the integral dy over g of y and f of t dt. Okay, so you see like dy, right? dt, g of y, f of t. Dy right here means like your integral is respect to y. dt right here, so your integral is respect to t. So variable is this one is t, variable is one is. Then step 3 is you solve for y. Right, because like from beginning, right? When you see like dy over dt, it means you need to find y of t. So the final step, the step 3, is you solve for y. Maybe you will use some technique like rearrange rearrange like, or you isolate variable y, um, maybe 5y. Yeah. This step is for some using some algebra to solve for y. So basically, like solving separable differential equation, just follow these steps right here. Any questions so far? That kind of makes sense. The good thing right here is if you have like t to here, for example, like after you separate, you have like one side missing y and t. You cannot like integrate it, integrate it. Because right here is y is the function only one variable. Y is this, the function have only one variable t. So it means like if you integral, right, with one side you have t. So it's not like makes sense. So make sure like one side is only y and one side has only t. Okay, so let's do some example to see that. Example, we have for start the while v, I mean v of t of a cell at time t change according to equation like dv over dt equal sine t and with initial condition v of 0 equal 3. Okay, so you need to find v of t, right? So like you see that this equation, right? This is differential equation, right? And you have dv over dt. So like I say, like whenever you see like dv over dt, it means you want to find v of t. So v is a function of variable t. T is independent variable, and v is a function of t. And also like that one, you only have sine t, right? So you try to separate them. How you can separate them? Okay. So if I time both side by dt, this one gonna cancel out. So I only have dv sine t dt. So the left hand side I only have v, and the right hand side I only have t, right? So I can integrate both sides. So what is the left hand side here? Integral of dv is just v. Integral of sine t dt is negative cosine t. And because like the integral right here, we don't have limit, right? This is a indefinite integral. So we need to add c. We only add c in one side. Think about like if you add c on the left side, left hand side also. So still the same. Think about like if you add c for both sides. like I add C1 here. So I can like subtract both sides by C1, right? So C1, C minus C1 here is just the other constant, just like the other constant. And the constant you can just apply by the new constant. Because like the constant right here is only depend on the initial condition. So based on initial condition, you will have like the unit constant, right? So the constant right here is mean like the solution is the whole family. You have many functions, but when you have initial condition, you only have a unit solution. So you need to add C both sides. So we just add C one side. Okay. Think about like if you write C here, right? Like and I write C here, and someone they don't like to write C. They write like 7C. Still right. It's still correct because like C and 7C is just the constant. It's just a constant. So if I write out like C plus C here, which initial condition right here is V0 equal 3. I need to find C, right? So I put in like the initial condition is V0 equal 3. I put in to find the value of C. So let me see what is that. So what is V of 0? V of 0 is mean you replace the value 0 here to T, right? Because like V is a function of T. So V of 0 is just replace T by 0. So negative cosine 0 plus C. And that is equal 3. What is cosine of 0? Cosine of 0 is 1. So you have negative 1 plus C equal 3. So C is just equal 4. Right? So the final answer V of T is equal negative cosine T plus 4. Yeah. Just plug in and to find C. Whenever the question gives you initial condition, you need to find the unit solution. It means like you need to find C, then put in, you have the unit solution. That one is unit, not the whole family. When you have C right here, it's the whole family. They call like general solution. They call like sometimes they call like the general solution. The whole family solution. But with like the initial condition, V0 equal 3 here, you will find only one C. So that one is unit. Maybe like this one is specific solution or particular solution. Okay, but you don't need to know. Yeah. I just introduce like some definition in case some of you guys you said like math 46. Okay, back to like the case like if someone they don't like to write C, but they write like for example they write like 7C. I show you. So if they write like V equal negative cosine T plus 7C, right? And with initial condition V0 equal 3, I plug in, right? So I get like V of 0 equal negative cosine of 0 plus 7C equal 3. So I still have negative 1 plus 7C equal 3. So 7C equal 4, right? So C equal 4 over 7. So if someone write this for the general solution, 7c. So their c is 4 over 7. So when they put in the solution gonna be equal negative cosine t plus 7 times 4 over 7. So it still have, you guys see that? It still have the same. Yeah. Yeah. Even like someone write like C, someone write like 7C, but with the same initial condition, 3 of 0 equal 3. They still have like the same particular solution. So like say like the constant, you can replace by the other constant. So right here you see the constant, so you can replace by the other constant. And also like C minus C1, whatever, like they are constant, it only depend on initial condition. You can replace by the new constant. Okay, that one right here, just try to explain for you for next problem, maybe some complicated problem. You need to like simplify the constant by a new constant. Okay, so any question for example one? This one be easy, right? Because we know how to evaluate the integral. The integral is easy to evaluate. Yeah. If no question, let's move to example two. Okay, so example two, we have dy over dx equal 2 minus 3y with initial condition y1 equal 1. Okay, so look at this differential equation. You have dy over dx. So it means we want to find y of x. Right? So we want to find y of x. Okay. So the first step is you try to separate the variables. So dy over dx, and that one is 2 minus 3y. So how you can separate them? For that one right here, you think about like the whole thing right here is the f of y. I mean like g of y based on this one. Right. Like when you try to separate the variable, you need to have the in the product. This one is multiplication, the product, the multiplication, not the sum. That one like you have to read, you have to look, you have to see this one as a product. Yeah. So you need to see that one is just time one. Okay. So how you can separate them? You just divide both side by 2 minus 3y. 2 minus 3y. 2 minus 3. And time both side by dx. So that one you can cancel out dx. This one you can cancel out 2 minus 3y. So the left hand side is dy over 2 minus 3y. and the right hand side is only ds. Okay, this is an important step. Like don't do this one. Don't do like this. Okay, uh, because I when I teach math 46, many students like they messed up like the first step. They do like this. They move to, or maybe they put like this. If you do like this, how you can like integrate both sides, right? Because like this one you still have the axis, right? So if you time both sides by ds here, so you still have like dy, right? Plus 3y ds, right? So how you can integrate this one? Because this one you have dy plus 3y ds. Okay, so don't do that. Don't do this one. Don't separate like that. Okay, view that like the product. Because like from beginning when I introduce you guys about the definition of separable differential equation, we have like the product here. F of t times g of y. Okay, so how you can integrate both sides? What is the left hand side? Anyone? What is the left hand side? We have formula of that one. This one is degree 1, right? So we can use this formula. Okay, you can use this formula. But like the coefficient right here is -3, -3, right? So you have to divide by -3. So that one is just equal -1/3 ln of 2 minus 3y absolute. The right hand side, the integral of dx is just x plus c, right? Okay. It means like we already like evaluate the integral, but we need to find y, right? We need to find y. How you can find y here? So because I the left hand side I have -1/3 here, so I can time both sides by -3. I will get like -3x minus -3c. -3c right here, right? -3c right here is the constant. Constant only depend on independent variable. So I can replace -3c right here by the other c. Right. Think about like the problem I just give you like the thing here. If you write c and you write 7c, still right. Because like the constant right here is only depend on initial condition. So with initial condition, you can find like c. So the same thing here. I have like negative 3c, just the other constant, just the constant, right? I just replace that by the other constant c. Yeah. Okay, how can I solve for y in this case? I have ln, right? So to find y inside the ln, I use some property for the logarithm function. So I e both sides. Okay, recall that e to ln a equal a, and e to power a plus b equal e to power a times e to power b. Okay, so the left hand side now is only 2 minus 3y absolute. The right hand side I will have e to power c times e to power negative 3s. Right. E to power c here. This one is a constant. E is a number, c is a constant. So e to power c just a constant. So I can replace by the other constant. So I can replace that by the other c. Okay, then absolute of 2 minus 3y equals c times e to power negative 3x. I can get like plus and minus. Right. Remember, you have like s, the absolute of s equal a. It means like s equal plus and minus. Okay, also like plus and minus c here is still the constant, right? This one is constant. So I can apply by the other constant. So I can apply that by the other c. So I have, if I subtract both sides by negative 2, that one cancel out. I will have negative 3y equals c times into negative 3s minus 2. So y is equal negative c over 3 times e to negative 3s then plus 2 over 2. So this step I just divide both sides by negative 2. And again, I have c over 3 here. Negative c over 3 here is constant. So I can replace that by the other constant. Okay, so this is the whole family of solution. The question gives you initial condition, which is y of 1 equal 1. Y of 1 equal 1. So you can plug into phi c. The initial condition is y of 1 equal 1. So you put in. So what is y of 1? Y of 1 means you replace x by 1. So y of 1 equals c to e to negative 3 plus 2/3, and that one equal 1, right? The one here is 1. 1 here you apply by s, apply by 1. Okay, so c e to power 3 plus 2/3 equal 1. So c e to power 3 gonna be equal 1/3. So c equal 1/3 times e to power 3. So after you find c, put to here, right? You get the final answer is 1/3 e to power 3 times e to negative 3x plus 2/3. Or maybe you can simplify more by this. Okay. So you see, like the important part is the important thing is you can replace the constant by the new constant to make the problem easier. Right? Yeah. If you just keep like right like for example like right here, you if you keep like right like negative 3c e to negative 3c, and you keep you write like the constant with like complicated term. Mean like when you try to find the value c, it's too complicated. So the technique you learn from this one is really important, really important. Whenever you see like the constant is only depend on initial condition, you just apply that by the new constant, just the other c or k or whatever. Any question? So I have a question. So if s go to infinity, what is void? Based on like the equation right here, if s go to infinity, what is void? Right. Yeah. Yeah, 2/3, right. Because if s go to infinity, this one gonna go to 0, right? So whole thing will go to 0. So you only have 2/3. Maybe you can write like the limit s go to infinity of 1/3 e to power 3 e to the negative 3x plus 2/3 is just 2/3. Or you can write like 1/3 e to. Okay, so s go to infinity, this one gonna go to infinity. So you have a number. This one is just a number, right? 1/3 times e to power 3 is a number. You divide by something that goes to infinity. So it means that one is just 0. So 0 you plus 2/3 is just 2/3. Okay, let's do one more example. This one is kind of like complicated. I mean, like if I test you on the final, I will test you something easy like this. but not like problem 3, but like let me give you like the example 3 right here, and you can see like the important thing is you replace the constant by the new constant to make like problem easier. That is just like the skill. I mean like the skill, when you practice you can have the skill. That's why like tomorrow I will give you some problem and you can work on with your classmate. And if you have questions, I can help you like to do the problems. Yeah. dy over dt equal 2 times y plus 1 times y plus 2 with initial condition is y of 0 equal 2. Okay. So it means like you see like dy over dt here, right? So you need to find y of t. So we need to find y of t. Okay, the first step you need to separate them. How you can separate them? This one you have y plus 1 times y plus 2, right? So you can just divide both sides by y plus 1 times y plus 2. And you time both sides by dt. So after you do that, you will get like y plus 1 times y plus 2 and 2 dt. Right? I just divide both sides by y plus 1 times y plus 2 and times both sides by dt. I got dy over y plus 1 times y plus 2. And the right hand side, I got 2 dt. Now I can integrate both sides right? Because now I only have left hand side only have one variable is y. The right hand side I only have one variable is t. Okay, so I integrate both sides. What is the right hand side here? The integral of 2 dt is just 2t plus c. Right? What is the left hand side here? The left hand side here, the integral from the left hand side, we need to use the partial fraction decomposition. Okay, because like you have like 1 over y plus 1 times y plus 2, so you will need to use that. Yeah, we just learned partial fraction decomposition last week. Okay, so let's do partial fraction decomposition of this one. Okay, so this one you can write like in the form y plus 1 plus by plus 2. So remember, we need to find the coefficient capital A and capital B. So how you can find that? You can combine two fractions here. So that become A times y plus 2 plus B times y plus 1 over y plus 1 times y plus 2. You can see like the numerator has to be equal because like the denominator already equal. Okay, remember this one is equal for all y. So we just need to put like some easy easy case. So you can put like y equal -2 or y equal -1 to kill some term. For example, like if I put y equal -1, right? I pick y equal -1, so this one gonna be 0, right? So the left hand side I have 1. The right hand side I have a -1 plus 2. So I have a, right? So a equal 1. Also, if I put y equal -2, so the left hand side is still 1. Y equal -2 plus 1 is just 0. So I have b -2 plus 1. So 1 equal -b. So b is just -1. Okay, so it means like the integral of dy over y plus 1 times y plus 2 right here is can be written as a, right? A over y plus 1, so a equal 1. Y plus 1, b equal -1. So y plus 2 dy, right? Because I the thing right here, 1 over y plus 1 times y plus 2 equal a, I get 1. So I got that one. b is equal -1. So I get -1 y plus 2. After I do partial fraction decomposition, I can evaluate the integral, right? So the integral of 1 over y plus 1 right here is ln of y plus 1. The integral of y plus 2 right here, I can write like ln of y plus 2. Okay. So it means like the left hand side here, after I evaluate the integral, I will get ln of y plus 1 minus ln of y plus 2. Or I can combine them, right? I can just combine them. So because like ln of a minus ln of b is equal ln of a over b. Okay, so the left hand side of equation I get ln of y plus 1, y plus 2. The right hand side is 2t plus c. 2 plus c. Yeah. You find something like something I something interesting here, like why I didn't put like the absolute integral of 1 over x dx is equal ln of absolute of x, but why I don't put absolute? Why in this case I don't put I didn't put absolute? Anyone know? What we are doing right now is we try to solve the equation. We try to find the solution. And why I don't put absolute here? Look back to the example 2. Right, I put absolute here. But after I put absolute, I have like plus and minus. And the plus and minus c here, right? It can be absorbed to the constant c. I can place like a plus and minus c here. to the new constant c, right? So it means like the thing I put absolute here doesn't matter because like after I solve that, I will have like the plus and minus, the plus and minus the constant c just replaced by can be replaced by the other constant c. That's why like in this one we don't need to put like absolute because like, if you put absolute, it's still right, but like after that, if you solve for y, you can just replace the plus and minus become the constant, absorb to the constant. Okay, like similar to the previous problem, you have ln, right? Y is inside ln. Y is inside the ln. So to find y, you need to e both sides. Okay, so now the left hand side is y plus 1 over y plus 2. And the right hand side is e to power c times e to t. Okay, e to c here is constant, right? I can replace that by the other constant c. Okay, so y plus 1 over y plus 2. I can apply by the other constant c. Yeah. Okay, let me write down it clearly. Let's play like what. So because e to power c is a constant, only depends on initial condition. Then we can replace e to c by c. C right here is also constant. Only depend on initial condition. Yeah. Okay, so we finish this step, but we need to find y, right? We need to solve for y. This one is not solved yet. We have like I mean like we have equation between y and t, but we need to solve for y. How you can solve for y here? So you just times both sides by y plus 2. So we have e times e to t times y plus 2. Right? So you try to isolate y. Okay, so we move y to the one side. You have y minus c times e to t times 1. And you move 1 to the other side. You have 2c e to t minus 1. I mean, Okay, so I factor out y. I have 1 minus c e negative to power e to t. And that one I have e c e to t minus 1. Then I can divide both sides by 1 minus c e to t. I get 2c e to t minus 1 over 1 minus c e to t. Okay, it means this is a general solution. Minus 1 over 1 minus c e to t. Okay, and they give you initial condition, which is y0 equal 2. So you need to find c, right? Whenever the question gives you initial condition, you need to find c. The initial condition is y0 equal 2. You put it. You have what is y0? Y of 0 is 2c e to power 0 minus 1, 1 minus c e to power 0, right? And that one equal 2. E to power 0 is just 1, right? 2c, so that one is 1. So minus 1, 1 minus this one also 1, so only c equal 2. So you need to find c. 2c minus 1 equal 2 minus 2c. So 4c equal 3. So c equal 3 over 4. After you find c equal 3 over 4, you can plug back to the y of t. So you have like c here by 3 over 4. So 2 times 3 over 4 is 3 half. E to t minus 1. 1 minus 3 over 4 times e to t. Okay, this one is the solution, the final answer. Also, like similar to the previous problem, I have question. What is the limit t go to infinity of y t? What is the limit in this case? If t go to infinity, what is y of t? Any other answer? 0 is close. Okay, so how you can see about in here and in here. Maybe like Okay, let me show you. Okay, so y of t is 3 half times e to t minus 1, 1 minus 3 over 4 e to t. So the thing is, we don't know that one, right? How about I divide the top and the bottom by e to t? I divide everything by e to t. Okay, so I just divide the top by e to t, the bottom also by e to t. I got this one. Okay, so let me see what is that. That one right here, it becomes 3 half, right? That one is 1 e to t. That one is 1 e to t. That one is 3 over 4. Right. I think high here is 3 over 4. Okay, now you can see when t go to infinity. When t go to infinity, this one go to 0, right? Because you have 1, you divide by something in infinity. So that one is just 0. Also, this one is 0, right? So means you have like 3 half, you minus 0, 0 minus 3, 4. So it's just 3 half divided by 3, 4. So it's just -2. Yeah. Or you can just look at the coefficient. The coefficient here is 3 half. The coefficient here is -3, 4. So you just apply the coefficient 3 half, you divide by -3, 4. So you have -2. Yeah. Yeah. Any question about everything for this problem and about everything? Any concern? Like I said from beginning, to solve differential equation, you just follow step by step. But the tricky part is you need to using your skill, your algebra skill, your solving skill. Like for example, like if you don't know like ln of y plus 1 minus ln of y plus 2 equal ln of y plus 1 over y plus 2, you can like solve that one, right? And if you don't know like e to ln of y plus 1 over y plus 2 right here, it's just y plus 1 over y plus 2. How you can solve that one? Yeah. Even like the problem 2, right? If you don't know like e ln equal a, e to power a times e to power b just e to power a plus b, like this one. How you can solve for one? Okay, so tomorrow we do some activity on separable differential equation. We just learned today, and trig substitution we learned yesterday. So I kind of give you 2 or 3 problems. So make sure you working on with your classmate and ask me if you need help. But like for activity 1 and activity 2, I just grade based on attendance. It means like you just turn it, I give you free 8 point. But like for activity 3, you need to finish the problem. Because for activity 2, some of you guys just give me like the paper with like, and you didn't even try to do the problem. So for the activity 3, in order to get 8 point, you need to finish that. Even like you give me like the wrong answer, but like I just want to see like you try to do the problem. Okay. Yeah, I will post the note for today. So I suggest you to look at the note. Yeah, look at the note like especially for problem 2 here. Because I on the test on the final you will see like problem similar to problem 2. I mean like if I test you problem 3 is still doable, right? But it's just too long, right? Because you need to like for that one right here you need to use a partial fraction decomposition. And partial fraction decomposition I will test you separate question. Yeah, I will test you like one problem in partial fraction decomposition, but like separate problem is not inside the solving differential equation. So I'm not going to give you like something like problem 3 on the final, but I will give you something similar to problem 2. I just change the number, like like instead of 2 minus 3y, I can write down like 1 plus 2y, or even like 1 minus y. Yeah, similar to that. So I suggest you to look at like problem 2, and we will practice that tomorrow in person. Okay. Any question, any concerns?